Right. So I want to welcome you back to pre-calculus. We're going to go ahead and hit next problem in line here, which is going to be number 6. So this is section 3.6, number 6. So a certain substance decomposes according to a continuous exponential decay model. To begin the experiment, initial amount of 6,200 kilograms. After 6 hours, a little less than half is left. Okay. So what they want us to do is to come up with an exponential decay model, and then they're going to ask us a little bit later. This is a very standard problem. I would have no problem asking you how to do this. Like, it's a good quiz question. This is kind of the perfect one that I would do with. Okay. So let's see if we can't start this. Perfect. All right. So here we go. We have, okay. Sometimes the book uses Q, sometimes it uses A. It doesn't really matter which letter you pick. So we're going to have Q equals Q sub 0, e to the KT. Okay. That's our continuous. You have to memorize a formula like this, okay? I don't care how you spell them. In biology, they spell it this way. P is equal to population 0, so P naught, the initial population, e to the KT or RT. And if you're doing banking, if you're doing interest, it's A amount equals principal, e to the RT interest rate. Just change it to a decimal. Just that's one thing. If it's the APR of 6%, you've got to change it to 0.06, okay? Whatever the APR is, you got to change it. But in this problem, they don't tell us what the decay model is. They don't tell us what the rate is. They give us enough information to figure it out, but they don't tell us what it is. This is exactly the kind of problem I would give to you. Okay, so I want you to realize, like, this is exactly what you're on the hook. Okay, if you're a pre-calculus. Okay, so let T be the time in hours since the beginning of the experiment. Okay, we're going to figure this out. Okay, so what information do we have? After 6 hours, we have 2914 is left. So 2914 is equal to, how much did we start with? Right, it looks like we started with 6,200 kilograms. So we have 6,200 here. E, and then T is in hours, right? How many hours have passed? So we have 6 hours. And then we have some kind of a decay rate. I don't know what that is. That's our first job, is to figure out, find K. Okay. So the first thing we have to do is figure out our decay rate. So that's what we're going to do. Right. So the goal here, solve for K. All right. That's just the plan of what we're going to do. So yes, we are going to take a logarithm, but I don't want to take a logarithm because this is going to be messy. So the first thing I'm going to do is divide both sides by 6,200. Just like, you know, when you took square roots, you wanted to clean it up as much as possible. So when you took the square root, it was a clean square root. You didn't have a bunch of extra stuff there. So I've got 2914 divided by 6,200. Okay, I don't know if that reduces. That is equal to e to the 6k. Okay, so now we have to get, we have a variable, we have an unknown in the exponent position. How do we get it down? Well, we take natural logs on both sides. Why natural logs? Because natural logs are base e. Okay, so I'm going to go ahead and take the natural log 2914 divided by 6,200. Okay, is equal to the natural log of e to the 6k. Whole point of doing that is so that this bit can come down in front. That is rule 3 of logarithms. This is not a calculus thing. This is just a rule 3 from logarithms. So we have 6k times the natural log of e. Okay, that's why we pick natural log. I'm asking, well, e raised to what power, right, is equal to e? Put a 1 here, then that's our answer. So the natural log of e, that's going to be 1. So we have 6k. Over on the other side here, we have natural log of 2914 divided by 6,200. So k is equal to 1/6 times, or you can say this whole thing over 6, that's 4. 1/6 times 2914 over 6,200. Okay, this is extremely susceptible to round off error. You want to make sure that I usually tell my classes that 4 significant figures on this is the appropriate accuracy to go to. What did they tell us in the problem? This is a problem. Okay, so we can check to see if they wanted us to do that. We use the exact expressions to use them as parts of the formula. So they didn't really want us to round off at all. So they're okay with leaving this as a mess and just having k equals 1/6 natural log 2914. The only thing I'm going to do is I'm going to type this in. So I'm going to say we have 20. So this is a little cheat here. And remember being in 5th grade and having the teacher tell us, like, you're going to have to learn how to reduce because the calculator is not going to do that. Okay, so we have that. So that didn't give us a very nice thing, but what we're going to do is we're going to go to math, we're going to go to fraction, and we're going to change this number into a fraction. I want 47 over 100. So we, rather than typing in all of those digits, we have 1/6 natural log 47 over 1. It turned out to be a nice number, so we actually could just say 0.47. That's fine, but Alex might get mad at us because they're expecting a fraction. Okay, but that's how you change a number that you don't know if you reduced it well. That's how you make the calculator reduce it for you. Okay, so that's what we're going to have. Okay, so what are we going to do here? We're going to say, okay, well, we need the beginning amount. Okay, so the initial amount was 6,200. Okay, so we have the initial amount that was 6,200. And then we have E, like, what's K? Just found it, right? K was 1/6 natural log. So we have 1/6. 1/6. Where's my over 6? ln. Notice they have a little ln here. We're going to do that. And we're going to say 47 over 100. And all of this stuff is inside of the natural log, so we don't have to worry about that. Okay. T is in hours. Okay, so we come back down over here to say 16 hours. Okay, we don't have to worry about this too much. Okay, so we're going to say, okay, this is y is equal to 6,200, just like we typed in. Okay, just like we typed that up here. Okay, 6,200 e to the 1/6 natural log of 47 over 100 times t. In this case, what is our t? Okay, what do they want us to find here? They want 16 hours. So we're going to change this t to 16 here. So we have y equals 6,200 e to the 1/6 ln, and then we have 47 over 100 times t over 16. Now you could change this. We could say this is e to the 16 over 6 ln 47 over 100, because in the exponent, right, it's multiplication. So if we have 2, 3 times 4 times 5, I can say this is 2 times 5 times 3 times 4. That's all we're doing, just changing the order in which we're multiplying. So the way I put this 16 over the 1/6, I'm just changing the order in which this multiplies. Okay, so this is 6,200 times all of that. Okay, and whatever works best for you, that's how I want you to do it. Okay, so I want you to be right, but if it's not breaking any rules, you're allowed to change the order in which you do things. That's fine. We're going to say 6,200 times, and then second function, ln, okay, and that'll give me e to the. So we're going to say 16 over 6, okay, times, and then we have natural log, okay, and then we have 47 over 100. You can probably say 0.47 at this point, that's fine. Okay, and parentheses, and then that's one of them, and we're just going to double check it for the next parentheses. That should be everybody. That should give us, yeah, that should give us everything we want here. So we're going to go ahead and say that. So I have 827.9. How many decimal places did they want? Okay, they wanted nearest whole number. Oh, thanks. Okay, we don't have to worry about any decimal places. So I'll go back to my calculator, nearest whole number. So we're going to say, how about 820, 820, we're going to round this up. So it's going to be 828. 828 kilograms. 828 kilograms. How about 828? 828. Okay, some things to think about. Okay, the half-life of this thing was 6 hours, or no. They said after 6 hours there was like a third of it left. So this is after 16 hours, so it's going to be like, well, that how many six go into that? It's like 2, 3-ish, 2.5. So the fact that we are now going to see rest of this. Okay, so we're going to go ahead and check this. So we've got that, and then Ray, I think we got a little box here, so we're good, and we'll continue that one. I'm going to stop recording and then talk to something else. We'll see you in the next video.